Welcome to Mrs. L's Math World. Today we are going to have a look on the trigonometric identities, which is in page 10.12. So before we go on how to check out the identities, so let's recall something, which is the example we've done before to calculate for the corresponding sine, cosine, and tangent. So if you remember, when we are calculating for the values of sine, cosine, and tangent, which is in different costs of quadrants, so you can discover that whenever you do calculations, the values of the trigonometric identities, means the sine, cosine, tangent, is almost the same as before, but the difference is you will got the difference in the sign. If it is the quadrant is go to positive like tangent in quadrant 3, so it is still positive, and the value of the tangent is still the same. The reference angle refers to quadrant 1, if you remember. For acute angle, it is for quadrant 1, acute angle. And for other quadrants, it just depends on the sign of positive negative. So you see this one is negative, but you see the value, they are the same. Alright, so similarly, it also works for cosine and sine. So let's move on to the next part. That means we go to the trigonometric identities. So there are two types of the trigonometric ratios. The first type is 180 degrees plus or minus theta, 360 degrees plus or minus theta, and also minus theta. The second type will goes for 90 degrees and 27 degrees, 270 degrees. Alright, so how to check out for the sign or the values? So right now here is an example on how to handle with quadrant 2 and quadrant 3. There are 180 degrees minus theta and 180 degrees plus theta. Alright? Okay, so for the first one in quadrant 2, this is quadrant 2. So you get the theta acute angle on the plane, and you can see that actually 180 degrees minus theta is handled in this way. Alright, and for the values of the sine 180 degrees minus theta, and when we calculate for the values of sine and cosine, it's actually the same as before. Just the difference is you need to check out for the value of the sine. Okay, this one I should put the negative also. We put negative x, yes. Alright, okay, so you can see if I want to calculate for the values of sine 180 degrees minus theta, it's actually the same as the normal way to find, means y over r with this positive sign as in quadrant 2. But for cosine, you see that this is negative x, negative, but the r is still positive, so it becomes negative cosine x. Alright, so lastly, we also get calculate for the values of tangent 180 degrees minus theta. We refer this triangle again, and then we can get the values to be negative. But of course, it will be the same as tangent theta inside, because y over x means tangent. Okay. And then it's actually similar to calculate for the case of 180 degrees plus theta. So this one is quadrant 3. For 180 degrees minus plus theta. So in this case, it is shown to be quadrant 3 in this way. So make sure you understand how the triangles is. Actually, you can see again for the trigonometric ratios for the values, they're the same. But only difference is we got the plus or minus sign. And for the plus sign is also the same as before. That means only tangent is positive in quadrant 3. And then in quadrant 2, only sign is positive. So that means the CAST can still also be used in this case. And one more thing is, all the sine, cosine, tangent, they will be the same. As a result, in this table for this part 1, we just need to handle for the cases when they are positive, when they're 180 degrees and 360 plus or minus. And then just check for the quadrant. Quadrant 2 still go for S, quadrant 3 still goes for T. But then this is a little bit strange, right? You see that there are 2 cases, they are on quadrant 4. Minus theta, this case, is also quadrant 4. Because minus theta is here, which is lies in quadrant 4. Or if you think it is difficult to remember, you can also remember in this way. Because if you want to calculate the values of cosine negative theta, for example, then it is equals to the value which is plus 360 degrees. Because it is always the same trigonometric ratios when we add a cycle. So this one belongs to quadrant 4. And as a result, it's equals to positive cosine theta. So let's move on the next part for the examples in the notes.